Hey guys, in this video I am going to speak about one of the most important concepts in Java, that is polymorphism. Okay, so in my previous videos I have discussed about the concept of encapsulation, inheritance and abstraction. So if you have not watched those videos, please go and watch those videos first before coming to this video, then it will be very much clear to you. Okay, so in this video I am going to discuss polymorphism. Okay, so please watch this video till the very end. Okay, so first of all, the essence of many forms. How a single entity behaves differently depending on the context. Okay, so literal meaning derived from Greek, polymorphism means many forms allowing the same method to behave differently. Okay, the person analogy. A single father can be simultaneously be a father, an employee, and a friend. Same person, different role. And functional flexibility. It helps developers achieve high flexibility and reusability by decoupling behavior from implementation. Yes, I know that this is not understandable. So now I will show you by the help of one example. Okay. So let me open. So I'm going to show you by the help of an example. Okay. So first of all, let's declare one class, that is polymorphism. Okay. So there we'll have a function that is public void polymorphism. Okay. So this is a method over here. So this method is having some arguments, that is int a, int b. Okay. So these are the two arguments in the method. Now let's declare another method, that is public void polymorphism 2. Okay. So this is having three arguments, int a, int b, int c. Okay. Suppose this one returns the result as return a plus b. Okay. Suppose this one returns the result as a plus b plus c. Okay. So this is the method name is the same, but different argument is there. Okay. So now let's get back to the PPT. So this is polymorphism. Okay. So now we'll discuss about classification of polymorphism. Okay. So there are two types of polymorphism, that is compile time polymorphism and runtime polymorphism. So compile time polymorphism is known as static polymorphism and runtime polymorphism is known as dynamic polymorphism. Okay, so compile time polymorphism is achieved through method overloading and runtime polymorphism is achieved through method overriding. Okay, so the example that we have seen over here is known as compile time polymorphism. Okay, this is compile time polymorphism. And what is runtime polymorphism? The runtime polymorphism is when we see the example of inheritance. Okay, when you see the example of inheritance, one method is overriding the another method. So that is, or when you see the example of abstraction, one method is overriding the another method. So that is known as runtime polymorphism. I hope this point is clear. If you have any queries or doubt, feel free to comment down below and respond to each of your doubts. So now we will see the examples. Compile time, static method overloading. Okay, enhancing the code readability by using the same method name for different parameters. Okay, so overloading rules and math util example. So a concise subheading that supports the main message. Okay, so there are 3 parts. That is same method name within the same class. As we have seen over here, this is the same method name within the same class. So this is the class, this is the two methods, they have the same name. Okay. Different parameter list. Okay. So we have different parameter over the methods. Okay. So, and it improves the readability and consistency. Okay. It improves the readability and consistency. So here we are seeing one example, that is math util example. Int add and int add function. This is int a and int b. This is return a plus b. Okay. So here is another example, that is int a, int b and int c. 3 parameters are there and it is returning a plus b plus c. Okay. So we have seen in the same thing over here. Okay. Now method overriding. Now we are saying method overriding. Okay. So what is method overriding? Allowing the child classes to provide specific implementation of parent methods. This is known as method overriding. Okay. So as we know that in the inheritance example, we are creating base class and child class. Okay. So methods of the child class are inheriting the properties of the base class. So this is known as method overriding. Okay. So overriding requirements requires an inheritance relationship. Method name and parameters must be exactly the same. Okay. Uses override annotation as the best practice. Okay. So here, in order to achieve method overriding, you need to have the same method name and same parameters. Parameters cannot be different. Okay. And you should use override annotation as the best practice. So it requires inheritance relationship. Okay. So here is one example, that is parent class is animal class, child class is dog class. Okay. So the parent class is having one method, that is sound method, void sound, and the child class is inheriting the sound method. The child class, that is the dog class, is inheriting the sound method, that is override void sound. Okay. So this is the example of method overriding. So now dynamic method dispatch, the process of resolving method calls at runtime rather than compile time. Reference creation, create a parent reference. Example, animal to hold an object. Object assignment, assign a child object. Example, new dog to that parent reference. Method call, invoke the method, sound method of the parent reference. Okay. Runtime decision, the JVM determines the child's implementation is the one to execute. Okay. So overloading versus overriding. A technical breakdown of the key differences between the two types. Okay. So here the method overloading is compile time and the method overriding is runtime. In the method overloading, inheritance is not required. In the method overriding, inheritance is required. In the method overloading, parameters must differ. In the method overriding, parameters must be same. In the method overloading, the purpose should be readability. In the method overriding, the purpose should be specific implementation. Okay. So, real world payment systems. This is a real world example. Okay. So, in the real world, we have credit card, UPI, net banking. Okay. So, suppose in the credit card there is a pay method. Real world payment systems applying polymorphic principles to a scalable financial application. Okay. So credit card has the pay method with the bank authorization and the credit limit checks. UPI implements the pay method using mobile authentication and QR scanning. And net banking also implements the pay method through direct secure portal redirection. The strategic benefits of polymorphism. Why top tier engineers prioritize polymorphic design patterns? Code reusability. Write a generic code that works with any subclass object. Scalability. Easily add new payment methods or animal types without modifying the existing logic. Maintainability. Centralize the interface logic and keep specific behaviors isolated in child classes. Framework support. Frameworks like Spring and Hibernate, these are supported. Okay. So I hope that this polymorphism concept is understandable to you guys. If you have any queries or doubt, you can leave them in the comment section below. Okay, see, if you have not subscribed my YouTube channel, please subscribe my YouTube channel, like and share this type of video.